Okay, so looking at the National 5 2015 paper 1, first question is subtracting fractions. We have mixed fractions, so the first thing we need to do is change them into top-heavy fractions. So we've got 6 and 1/5, take away 2 and 1/3. So 6 whole units would make 30 fifths. So we have 30 from the 6 and 1 from there, so we've got 31 over 5. And we're going to be taking away 2 whole units make 6/3, so we've got 7/3. So that's our first step. So now we need to change it so they have a common denominator. So if we look at 5 and 3, the lowest common multiple, so the first number that's in both those times tables, is going to be 15. So we have 31 over 5, we need to change that to being over 15. So we have to times the bottom by 3, so we have to times the top by 3, which gives us 93. And then this one here, we've had to times it by 5. So we've got 7 times 5, which is 35 on the top. And this is where you get your first mark for this question. So you get your first mark for getting it over the same common denominator. Okay, so now we need to subtract those. The 15 stays the same, and we just subtract the 2 from the top. So we've got 93 take away 35, which is 58. You get your second mark here. You can change this back into a mixed fraction, which would be 3 and 13 over 15. But you don't have to. You get your marks for having it as a top-heavy fraction. Okay, so we're looking at question 2. We've got an inequality, so we've got 11 take away 2 times 1 plus 3x, and that is less than 39. So our first step we need to do is we need to look at this bit here, our bracket, and we need to multiply out our bracket. So the 11 take away 2 times the 1 gives us 2. And then here, because it's minus 2, it's minus 2 times 3x, so we get minus 6x. It's less than 39. Okay? And that is your first mark for this question, having multiplied out your bracket correctly. Okay, so we look at this. We've got 11 take away 2, so we've got 9 minus 6x is less than 39, because we've collected those numbers together. We now need to have our letters and our numbers on opposite sides of the inequality sign. So we take away 9, because this 9 on here is a plus 9. So we have to take away 9 from both sides. So we're going to get negative 6x is less than 30. And this is your second mark here. Okay? And then our last step is we need to divide by negative 6 on both sides. Just to get the x on its own, divide by negative 6. So here's where things change slightly from using just a normal equation. So we divide by negative 6, we get x on this side. We divide by negative 6, we get negative 5 on this side, because we've got 30, which is a positive number, divided by a negative, so our answer is negative. And then because we've divided by a negative, and it's an inequality, that means that our inequality sign changes direction. And our last mark in this question is for having the x is greater than negative 5. Okay, question 3 is circles. So if we look at our first line of the question, we've got that AC is tangent to the circle centre O. So AC is the line we've got along here. So we have AC here. And that's saying that this is tangent to here, with the point B being the point of contact. We know that anything that is tangent is at 90 degrees. So that means that the angle we've got here, so DBO, so we've got angle DBO must be equal to that 90, take away the 77, which gives us that that is 13 degrees. Okay, so we've now got the size of this angle in here. How is that helping us? So if we look at our triangle, which is ODB, this one here. This, from O to D, is one radius of the circle, and from O to B is another radius of the circle. So we can say that we know that those are isosceles, because those are the same size, so that means that triangle is isosceles. So that means that this angle in here is the same as the one down there. So we have the angle ODB is equal to angle DBO, which is 13 degrees. Right, so we've got all those angles that we've kind of got marked now. So we've got part of what we need to get our angle that we've been asked for, which is angle BDF. So we've got this bit. We need to find the size here. So we now need to look at this triangle DEF. So this triangle, if we look at the second line, we've got DE is the diameter of the circle and F is a point on the circumference. So one of the circle facts we should know is that any circle that's made with the diameter of a circle, the angle at the circumference is a right angle. So we now know 2 of the 3 angles in that triangle, so we can use that to figure out what the third one is. So we have angle EDF is going to be equal to, so we need to add together the 90 and the 64, which is going to give us 154. So that's those 2 angles there. So angle EDF is 180 degrees. Take away that 154 because we know that the angles in the triangle add up to 180 degrees. So that gives us that angle EDF is 26 degrees. So we've got to find the size of angle BDF, which is equal to angle ODB plus angle EDF. So that's going to be 13 plus the 26, which is 39 degrees. Okay, so your marks for this question were for having this angle here, ODB or DBO, having these ones, the 13 degrees, for knowing that angle EDF is 26, and then for adding them together to get your 39. Okay, question 4. We've got x minus 4 times by x squared plus x minus 2. Okay, so we start with our multiplying out process. So we have x times x squared, which is x cubed. We've got x times x, which is plus x squared. We have x times minus 2, which is minus 2x. If you get 3 of these terms correct, any 3, doesn't have to be the first 3, you get 1 mark. And then we've got minus 4 times minus x squared, so we've got minus 4x squared. We've got minus 4 times plus x, so we have minus 4x. And then we've got minus 4 times minus 2, which gives us the plus 8 on the end. So remembering that 2 negatives multiply to make a positive. And your second mark is if you have all of those terms correct. So now we just need to collect our like terms to get our last mark. So we've got our x cubed. We've not got any other x cubed, so we can just leave it. If we look, we've got this x squared, and we've got this one. So we have to add them together, so we've got plus x squared minus 4x squared, which gives us minus 3x squared. Then if we look, we've got this minus 2x minus 4x. Put them together and we get minus 6x. And then we've only got the one number on the end, plus 8. So we have plus 8. So our final answer, which gets us all our marks, is x cubed minus 3x squared minus 6x plus 8. Okay, question 5. We have a standard deviation question in a non-calculator paper. So that means that the numbers should work so that we don't need our calculator. So we have to find, same as always, our x and our x squareds. So we've got 1, we have 2, we have 2, we have 2, and we have 8. So we've got 1 squared is 1, 2 squared is 4, 2 squared is 4, 2 squared is 4, 8 squared is 64. Okay, we add all our x's together and we get 15. We add our x squareds together and we get 77. So now it's using our formula, so we've got s is equal to the square root of the sum of x squared minus the sum of x all squared over n divided by n minus 1. So we're going to have the square root of 77 take away 15 squared all over 5 then over 4. So 15 squared is 225 and we then have to divide that by 5. So we have 225 divided by 5. Don't forget, there's nothing wrong with putting over at the side little kind of remarks like this. So we've got 77 minus 45 over 4 all square rooted. So we've got our 77 minus 45, which gives us 32. So we have the square root of 32 over 4, which is the square root of 8. So therefore, a equals 8. And for this question, your marks would be for getting your sums of your x and your x squared, for substituting incorrectly here, and then for your answer of a equals 8 there. Okay, so question 6, we've got a graph. It's part of the graph y equals a sine bx. So our a is our amplitude. So it just says to state the values of a and b. We don't have to do anything else, so we have to find values for a and a value for b. So a is the amplitude, so that's how high the graph goes. So that's 4. So a is just 4. B, this b in here tells us how many waves we have in 360 degrees. Our graph has been really nice and shows us to 360. So if you see, we've got 1, 2, 3 sine waves. So B is 3. And you get 1 mark for each of those. So question 7, we've got a graph of a parabola and we need to state the values of a and b inside this. So we've got y equals x plus a squared plus b. Okay, so we need to know that the turning point is minus a, b. So if we look at our turning point, we've got 2 minus 4. So that means that minus a is equal to 2 and b is equal to minus 4. So we've already got our b, which is one of our marks for part 2. And then here we've got minus a equals 2. So if we divide by negative 1, we're going to get that a is equal to minus 2. And that is the first mark. Okay, so for part B, so that was all part A. So for part B, we have to state the axis of symmetry of the graph. So if we look at our graph is symmetrical through this kind of line that I'm drawing here. So that point goes through the x-axis. So our line is going to be x equals something. So we've got x equals a number. So if we look at again back at this, we've got a vertical line that's going through our x-axis. So every single point here, so this is 2 minus 4. If we keep going, no matter where we are on this line that I'm kind of sketching, our x value is always the same because it's the same distance away from the y-axis. And that distance is 2 because it's this 2 from here. So our axis of symmetry is x equals 2, and that gets us the last mark for this question. So for question 8, we've got to find the equation of a line joining these 2 points. So to find the equation of the line, the first thing we need is the gradient. So we need to remember the formula for this. So it's y2 minus y1 over x2 minus x1. So we've got our 2 points, we've got minus 2, 5, and we've got 3, 15. So it doesn't matter which you do, but if we make this one x2, y2, always remembering it's alphabetical, so it's always the x then the y coordinate. That one's x1, y1. So we substitute this in, we get 15 take away 5 over 3 take away minus 2. So we get 10 on the top, and if we're taking away negative, it's the same as adding. So we get 10 over 5, which you can simplify to just 2. So now we've got the gradient, we need to find the equation of the line, and we need to give it in its simplest form. So we've got this equation here. So we have y minus b equals m of x minus a. So this is another one that you need to remember. In the coordinates, we've got 3, 15. It's probably the easiest one to use because there's no negatives. We call that a and that b. So we can substitute in our gradient m and values for a and b. So we have y take away 15 equals 2 times x minus 3. Because it's asked for it in its simplest form, we need to multiply it out. So we multiply this out, so we get 2x, and we get minus 6, and we have y minus 15. We always want to have our straight line equations in the form y equals mx plus c. So that's kind of how they want it to be. So we need to move the 15 we've got here, and that 15 is negative, so we need to add 15 to both sides, and then we get y is equal to 2x plus 9. For this question, you get your marks for having your gradient, for substituting in, and then for getting it in its simplest form at the end. So for question 9, we've got to write these in size order, starting with the smallest. So first, if you look at these, we've got the cos of 90. We know from our kind of table that we've had to do that the cos of 90 is 0. Okay? If we look, we've got the cos of 100. We don't need to know the exact value of this. We just need to know what size it is. So if we look at our cast diagram, we have our A, S, T and C. This is 0 degrees, this is 90, this is 180, and this is 270. So the 100 degrees is going to be in this section here, somewhere around here. So that would be about 100 degrees. Okay, so it's in between the 90 and the 180, and in that section we know that cos is negative, so we know that that is negative. Okay, and then cos of 300 from the same thing is going to be between the 270 and the 360. So it's going to be kind of somewhere in here, roughly. So we know that that is going to be in that section where we've got the C. So we know that cos of 300 is positive. So we know that 1 is positive, 1 is negative, and 1 is 0, so we can put them in order from smallest to largest. So our smallest is going to be the negative one. So our order is going to be cos 100. Then we're going to have the cos of 90. Then we have the cos of 300. Okay, and it says we have to justify our answer. So you can say because cos 100 is negative, cos 90 is 0, and cos 300 is positive. So here your marks are for having them in the right order, and then your second mark is for your sentence saying why that is the right order. Right, we have here a question, 10 couples took part in dance competition, they've given the scores, and we need to calculate the median, the semi-interquartile range of these scores for part A. So part A, so to find the median in the semi-interquartile range, we need our list of numbers to be ordered, so we need to put them from smallest to largest. So if we look, 12 is our first one, then our next is 16, then we get 17, then we have two lots of 18, we've got 21, we have 22, we've got a 26, and then we've got two 27s. So, because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, our median is going to be halfway in the middle. So that's going to be in here is where our median is going to be. So our median is going to be halfway in between that 18 and the 21. So the median is going to be 19 and a half. because 19.5 is halfway between 18 and 21. So now we've got to find our semi-interquartile ranges. So to find this we need our quartiles, so we need our Q1 and we need our Q3, because our median is technically our Q2. So we're looking halfway in between, so we've got here Q1, because that's kind of, if we split it in here, that is now the median of those numbers that are that side. So the first half of the numbers, so Q1 is the median of those first 5 numbers. And then Q3 is the median of the last 5 numbers. So we've got Q3 is 26 and Q1 is 17. So our semi-interquartile range is Q3 minus Q1 divided by 2. So we've got 26, take away 17, divided by 2, which is going to be 9 divided by 2, which is 4.5. Our marks you get for this one are for getting your median, for having both of the quartiles, and then for your semi-interquartile range for part A. So part B, we need to take 2 valid comparisons between the scores in the first and the second rounds. So if we look at the median, so we can make a comment about the median. So on average, the scores in the second round were higher because the median is higher. Okay, so we need to remember we can talk about this either way. We can talk about the second round in respect to the first one, or the first one in regards to the second one. Second round were higher. Okay, and then if we look at our interquartile ranges, we've got 2.5 and we have 4.5, so it's kind of talking about the consistency, how close together all the marks were. So the second round scores are more consistent, and that's because the semi-interquartile range is less. So you get 1 mark for each of these statements. Okay, simultaneous equations. We have 3x plus 2y equals 17, and we've got 2x plus 5y equals 4. So we want to get either our x's or our y's the same. We'll get the x's the same. So we have to multiply the first equation by 2 and the second one by 3, so that we've got 6x in both of our equations. So we're going to have 6x plus 4y equals 34. And our bottom one, when we multiply, we're going to have 6x plus 15y is equal to 12. So we need to subtract our equations to get rid of our 6x's, so we get 0. If we've got 4y, take away 15y, that gives us minus 11y. And if we take these away, we've got 34 take away 12, we're going to end up with 22. So we're going to have y equals minus 2, because we've divided both sides by negative 11. So we need to now substitute that back in. So we've got 3x plus 2y is equal to 17. So we've got 3x plus 2 times negative 2 equals 17. So we have 3x, take away 4 equals 17. So we add 4 to both sides. We get 3x is equal to 21. We divide by 3 on both sides, and we get that x is equal to 7. So those are our answers. So our marks here are for showing that we've multiplied, so we've got our x's or our y's the same, kind of getting values for x and y, so following through the process, and then for getting them correct. So we've got an algebraic fraction. We have x squared minus 4x all over x squared plus x minus 20. So we need to factorize here. So we're looking at the top line. There is a common factor of x, so we can take that out. And we get left with x minus 4. Okay, here we need to simplify it. Because they've asked us to simplify, it means we can. and on the bottom we have a trinomial. We know we need to cancel something out, so we can kind of guess that we've got to have an x minus 4 so it cancels out. But if we look at this, we've got our multiply and add, so we've got to get something that multiplies to give us minus 20, but adds to give us 1. So we know that 1 is minus 4, so what other number can we have? So we've got minus 20, it's going to be minus 4 times 5. But if we add them together we get 1, so we know that's right. So we've got x bracket x minus 4 on the top, and then we've got x plus 5, x minus 4 on the bottom. So you get 1 mark here for having the top correct, and 1 mark for having the bottom correct. Because we've got x minus 4 both on the top and the bottom, they can cancel out, they go away, and we're just left with x over x plus 5, and that's our final mark for this question. Question 13, we've got 4 over the square root of 8, and we've asked to have that with a rational denominator. So that means we don't want the third, so the square root on the bottom of a fraction. So to get rid of that, we need to multiply by the square root of 8 over the square root of 8. So we get 4 root 8. The square root of anything times by the square root of itself, so square root of 8 times the square root of 8, the square roots go away, and we just get 8. So we need to now manipulate the third, so to get it in its simplest form. So we've got 4 and then square root of 8, so that's going to be 4 times 2. Square root of 4 is just 2, so we've got 4 times 2 times the square root of 2 all over 8. So we have 8 root 2 over 8. So we can simplify that to just give us the square root of 2. The marks here come for being able to rationalise the denominator to the square root of 8, manipulating your third, so getting one of these two lines, showing that you know kind of what you're doing, and then your final answer gives you your third mark. Okay, so we're on to question 14, which is the last one in the paper. We have to evaluate 8 to the power of 5 over 3. So this is asking us to get it as a number. So we need to know that we can change any fractional index into a root. So the bottom of our fraction becomes our root, so we have the cube root of 8 to the power of 5. So we can do these in any order. So we need to find what number do we have to multiply together 3 times to give us 8. So it's going to be, we just start trying numbers, so 2 times 2 times 2. So we get 4 times 2, which is 8. So we know we're going to have 2 to the power of 5. And 2 to the power of 5, so we need to take that 8, times it by 2, twice more, which gives us our 32, which is our answer. And our marks are for knowing to change it, and finally for getting the answer of 32.